Assalamu alaikum. It's a pleasure that I will present my talk. So, as has been said by Dr. Suhail, it's a new approach for scheduling tasks. So, before I will go to the agenda, I need to say that my talk will go deeper into the Hadoop big data. So, maybe the presentation of today by our keynote speaker has give all the details about big data. So some of the slides, I will skip them rapidly. So this is the agenda of my talk. So the main things that I will concentrate on is about the scheduler. After, of course, we have to give details about the Apache Hadoop. OK, so let me remind some who were not here this morning that yeah, the data unit has changed, and we are going to hear about this new data unit, okay? So I'm sure that some of you, you didn't know about the yottabyte, okay? And you didn't know about the brontobyte. So these are the new data unit that we will have to hear in the next coming years. And of course, even that when we will say petabytes, it's a huge amount of data. But these are the new data units that we are going to see and hear, and maybe manipulate in the next coming years. OK, fine. So I'm not going to redefine what it has been said by our keynote speakers this morning. So all I have to say is we have different categories of data that we need to manipulate. So essentially, they are divided into three categories. We have the semi-structured data, and this one are being, let's say, targeted by XML and email bodies. Unstructured data, so all the type of data that are being according to audio, videos, images, files, archived documents. And we have also the data that are coming from enterprise systems, so the CRM, the SAP, and ERP, and all these things. But the most difficult part is not how to treat the structured or semi-structured. All of this, we know how to treat them. But the most difficult part is the unstructured data. Of course, we have the Internet of Things, as it has been presented by Dr. Ahmed Jadidi today. We have a lot of number of devices that are going to be introduced or already there in the next coming years. And all of these are generating data. But this data is unstructured, unfortunately. And we have also the number of videos uploaded on YouTube. OK, you might say to yourself, why we need to treat this data? You need to treat this data because maybe you need to have a transcript of what it has been said on that video. Maybe you want to analyze some of the things, extract some of the things from that video. And also the number of pieces of content exchanged on social networks. There are 400 million tweets that are sent per day. And if you want to analyze them, of course, it will require a lot of time. OK, so continuing to talk about the unstructured data. So it's 800% growth in data volume within the next 5 years. So we need to find a way, OK, to treat this big amount. OK, and it's going to grow by 62% faster. OK, and 80% of the data, of the global data, will be unstructured according to Gartner in 2019. So within the next 2 years, which is a big amount. Fine. OK, so the solution. The solution is Apache Hadoop. OK, of course, this is the open source software for reliable, scalable, and distributed computing. OK, it has been designed to scale up from single server to thousands of machines. OK, why? Because one single computer is not able to treat this big amount of data. OK, so if you want to do it, so you need to have a cluster, and that cluster needs to get distributed. And on the top of it, you need to have a software for managing this data and managing this big data. And of course, try to have it distributed using HDFS, which is Hadoop Distributed File System. Fine, so for Hadoop, of course, I'm not going to talk about the commercial solutions, okay? So you have a lot. You have Microsoft solution, you have IBM, you have Oracle. But since I love open source and I am already being Linux certified as Red Hat certified engineer, so I will say that within the open source community, we have three main distributions. That is Cloudera and Hortonworks and MapR. So all of these ones, or all of these distributions, are free and can be used. According to our keynote speaker, he's saying today that open source does not mean free. I agree with him at a certain level, because once you get it free, you need to get trained. But getting trained does not mean that you have to pay, because nowadays everything is available online. So even if you want to get an expert on open source solutions, okay, so does not mean that you have to pay for that. So by the way, I just closed this small parenthesis. So by the way, this is the Cloudera Hadoop ecosystem, which is one of the possible solution provided by as open source. So the main thing is, of course, at the core, you will find the Hadoop structure, but on the top of it, you have a lot of, let's say, small solution, and every solution is dedicated to a specific topic. So the main topics that you need to have is you might have to do some batch processing using the MapReduce. You might need to have to do some analytic, okay, with SQL. In that case, you need to use the Impala. If you want to do, for example, machine learning, you might use the Spark, the Mahout. If you want to do a stream processing, you might need the Spark. So, by the way, all of these tools that are existing and are on the top of the layers, okay, on the layers that comes above about the yarn, okay, will give, okay, the opportunity to developers or users for selecting the way to treat the data. Of course, treating that data requires that the scheduler will decide, okay, which is the best way to treat it. You might say, if I want to make the data analyzed faster by just adding more computer in the cluster, but that one is very expensive, okay? So this is part of my research, is to go deeper into the scheduler in order to improve how the scheduler works and how it will give rapidly, let's say, the analysis of the data. Fine, so where is the scheduler? The scheduler is within what we call the resource manager, that is here, okay? And it's part of the yarn, okay, that needs to collaborate with the HDFS, which is the Hadoop Distributed File System. And we are going to have what we call the data nodes, which are the machines that you have in the cluster, and you have the server nodes, okay, that is going to distribute the task for them. So the main job of the scheduler, of course, is to distribute the tasks within the data nodes, okay? So distributing the task, okay, to the data nodes, there are a lot of ways of doing this. And this is part of, okay, it's part of the scheduler. So in order to achieve greater performance, an efficient scheduler need to be implemented. So this is part of the scheduler, okay? And there are a lot of scheduling techniques that are being used within the scheduler. And these are the main one. So we have the static scheduler, which they are using the FIFO, okay, the first in, first out. So as soon as there is a new task, okay, that is going to be assigned, it will be added to the FIFO list, okay? So this one's, of course, the allocation of jobs is done before the runtime, okay? So we have also another one that is the dynamic scheduler, where the allocation of job is done during the runtime, okay? But all of these techniques, okay, of clustering, of the scheduling, is done without prior knowledge of the type of the job and without having information about the status of your cluster and the status of your data. So the main one, or the new, let's say, or the main active research that is being involved with the scheduler nowadays is the resource availability. So we want to know the status of the data nodes. What is the load of the CPU? What is the load of the hard disk? What is the load of the networks? So before I will assign the job, I need to know the status of the data nodes before I will do that. Okay, and there is also another possibility of scheduling is according to time, because sometimes you might have a stream of data that is coming, okay, and you want to have immediate analysis of that data in order to take decision, for example. And this is the fourth way of scheduling within the big data. Fine. So my approach is the following. So I want to make sure that within the scheduler, I need to have the information on the data nodes, okay, about the CPU load, the RAM load, the I/O load, the network load, and additionally, because what has been available in the literature review is just they need to know about the four level of loading, which is the CPU, the RAM, the I/O, and the network load. So I have added another one, that is the type of the job. So I need to know the type of the job, because according to the type of the job that I want, or that it will be received to the scheduler knows, okay, which one should be assigned, and of course, to the data node. So the type of the job here is important, because if you want to use the Spark for those who didn't know it, it's a module that is existing within the Hadoop. It allows the treatment of the data in memory, because treatment of the data in memory is very fast, okay, compared to the MapReduce. The MapReduce is using extensively, okay, the hard disk. So with the Spark, so if I have a job that is going to be used, or going to use a Spark, okay, so I am sure I need to make sure that the data node have enough memory, and also the RAM load of the data node is not very high, in order to make sure that I will have yeah, okay. So by the way, so the type of the job is important. So for example, if I have, for example, an HBase, okay, so I am sure that the type of this job needs more disks, okay, access. And at that time, I need to make sure that I will find a way to have the I/O load very low, in order that I will have good performance for the task. So fine. So I came up with this resource load equation, okay, where it will have to check for every node the CPU load, plus the RAM load, plus the I/O load, plus the network load. And after doing some simulation, I came up with these values, okay? And this is the algorithm, so I have to check for every data node, okay? So before the scheduler will assign the job, there is one component that will check on every data node within the cluster, okay? Find, first of all, which type of job is going to be used. And I will use these parameters after making some simulation, okay, in order to make sure that I will give the scheduler, okay, the best way of having good performance. After that, I will sort the array for the source load, and after that, the task will be assigned to the data node. Fine. So I have presented a new approach for scheduling tasks and/or jobs in big data. Okay. In the futures, I will be try to focus by having some machine learning, okay, in order that the scheduling of tasks will be done efficiently and smartly, okay, using, for example, artificial neural networks to assign jobs for the data node. Thank you for your unit.